Okay, so this is how I do the Lego Robotics challenge lesson. Starting with this screen, I put the shortcut here. Double click on your prezzies. Intro to robotics. It's going. Make it big. I click on this home button to recenter it, anything. Okay. Then I'm just going to keep clicking on this right arrow here. There's an overview. You got the intro, the activity log, the programming, and a review. So it starts off with a short discussion, about 5 minutes, and you want to direct them towards control, body, and behavior. What is a robot? You could show, you could make a little connection with pop culture there, with Transformers video. I never play the whole thing. I got the volume down right now. Keep clicking. Why do we use robots? I give them a chance to read out loud. And I need some commas and stuff in here. They don't get tired, bored, or hungry. See, they're as big as Transformers. You got this little guy here. Sometimes we talk about it when we got more time, like how this one robot will put on one part over and over and over again, and ask them if they would get bored doing that same job, and they all say yes. And we talk about dangerous work that robots do real quick, and then we talk about everyday robots a little bit, real quick. And then it goes right into the activity log, which is from the Star-based curriculum, Robots Any Machine. Instructions are a program, control body behavior. The control is a program. The body can be in any shape. And the behavior, or the output, is the action the robot will do. And we get right in programming. Let's go straight to, it starts off with day 2 sometimes. If we start day 2, you'd start at this screen. We're going to start here because it's day 1. Then we kind of explain the mission and what they're looking at. Start on the starting line with their wheels of their robot. Should travel all the way down here to the 1 meter mark, and then travel back and stop. Then you got to have them adjust their workstations or have it already set up so that the cord that is connected to their robot matches the computer that they're using. And I have them center the monitors in between them so that the partners are sharing the work equally and nobody gets left out. So they find the icon. It's important that they pick the one on the very bottom of the screen, the small one. If they pick those big ones in the desktop wallpaper, it's already that's somebody else's program saved up there. Okay, so have them pick the one at the bottom. Click on the plus sign to start a new program. They clear out this window over here by clicking on that button. Then they double click on program up here and type their initials. Just the letters, no dots or spaces. The initials of their initials and their partners. Then we got to make a folder for it. They got to click on File, Save Project As. Important. Save Project As, not Save Project. Then they enter their school name, and usually there's more than one period for that school, so I have them do, for example, Diamond 1, Diamond 2, Diamond 3, so we could find them later. Turn on the robot. Takes a minute. It should make a sound. I always do a quick check, see if anybody's didn't turn on. And I always keep spare robots charged. And this is their guide to getting it done. The challenge is to answer these questions. This one and this one. This middle one, the turn, is given to them because there's just not enough time in a period to go through the trial and error process with this. So they click on this button, change it to on for seconds, and then they make a prediction here, predict how many seconds it will take their robot to travel 1 meter. And they discuss that with their partner and enter it. And you just do one block at a time. You start with this block, give them some time to go through the testing process with it and reprogramming and downloading. Okay, and we'll get to that in a minute. Okay, and then I give them the instructions for this after they've had a little time with that. This goes on for degrees. Their B motor, which is this one, will go backwards, so it's a negative 50 here. The C motor goes forward 50 power, and then it's going to turn 515 degrees. I don't know why it's 515 degrees. Maybe it's because it's two wheels turning at the same time. I'm not sure. Anyway, then the other part of the challenge, how many seconds does it take to come back? They got to change this to on for seconds. Guess how many seconds? Run their tests until they come up with the right answer. Okay, that's the whole challenge. Now, the next step, they have to download. They got to get used to downloading because they're going to do it a lot. Every time they make a change, they need to download. And here's a zoomed in version of it. That's the button they click on their program to download. And it won't download unless it's connected to the computer, obviously. But sometimes the kids forget that. Define the file. I have them center the robot between them, locate all 4 tabs, 1, 2, 3, 4, and instruct them to select the second tab by using this right button. I zoom in on this to make so they can see it, what I'm doing. And then the next step, they click here to move to select the tab they want. Step 2 is they click to find their school folder. It should say, once they move in here, it would say Diamond 1 or Jackson 2 or whatever. And then once their school folder is highlighted, they click the OK button, which is this one. Then it's open. And once it's open, they should see their initials right below their school folder. They need to move the highlighter down with the down key on it. And as long as their initials are highlighted and they press go, it's going to run their program. I also made a video. Me and Mr. B made a video. And you can use that if you want. So they find their school folder and click on their program. Here's the video. It takes a minute to start, but it'll go. Find your file. And there's volume on here, but I'm not. I got this plugged into a mic, and I can't have volume and a microphone at the same time right now. That's how you do it. You find the school folder. You click OK. Hopefully, yeah. Click OK. Then there's the initials right below it. ICLF. That's their program. Okay? That's how you do it. Then you want to instruct them on how to set up their test. They should line up the wheels behind 0 on their meter stick and run their tests and go through the engineering design process until they can make this thing do the whole mission. And they have to make adjustments. If it goes too far, they need to choose less seconds on the first and third blocks. If it goes too far this way, same thing. They may need to adjust the turn sometimes. Every robot's different for some reason. I don't know why. But you can have them. If it turns too much, they need a lower number. If it turns too little, they need a higher number. And they need to download every time and find their file each time. It's a little tricky, but they get it. Here's a little flow chart you can post up there. And you gotta tell them to be very resourceful. Use their partners, use their problem-solving skills. Try to solve things themselves. couple things we do help with are real technical issues, but we won't help them get the answer. It's something that's the challenge of the lesson. They have to try to figure it out. And then on day one, we just go do a quick review. We power down the robots by clicking the stop button a couple times and choosing the check mark. We hit Save Project. You go to File and Save Project on the program. It's very important that they keep their work for next week. And then I have them answer these questions as a class. Our objective was to program a robot. Did we do it? Yes. What are 3 things that all robots have in common? Control, body, and behavior. That's it. That is the lesson.